Hey guys, welcome back. So yesterday you guys learned a little bit about biomolecules, or another term that we could use is macromolecules. Today we're going to talk specifically about one of those macromolecules, which is proteins. With proteins, an example of a protein is an enzyme. So today we're going to be focusing on enzymes. So an enzyme, like I said, is a protein, and it's also a catalyst. So a catalyst is something that allows your reactions in your body to speed up by lowering the energy activation rate. Okay. So for example, we have a enzyme in our mouth and also in our pancreas that's known as amylase. And amylase is the enzyme that breaks down carbohydrates into monosaccharides or simple sugars. So if we're talking about amylase in our mouth, the more saliva that you have in your mouth, the more amylase you're going to have. So the more amylase you have, the faster the carbohydrates in your mouth are going to break down. Okay, so it's kind of acting as a catalyst. It is speeding up those reactions and lowering how much energy we need in order for that process to happen. So let's go ahead and start looking at how enzymes bind to substrates and what all this is kind of happening in this process. Okay, so let's start here. Lactase. So lactase is going to be our protein. So this is our enzyme. Okay, so if you notice, our enzyme has a very specific shape right here. We always have to have something specific fit into that spot. Okay, and this is known as lock and key. So what's going to happen is we're going to have a substrate. In this case, it's lactose. And that lactose molecule is going to have to fit right inside of our enzyme activation site. Just like a key fits into a lock. Okay, so if we take our substrate, it should fit exactly into our active site, into our enzyme. Okay, like so. Okay, an important thing to note about this though is every time we have an enzyme that binds, we don't use up that enzyme. We can always reuse the enzyme. So for example, if we had another lactose come along, once this reaction has occurred, another one's going to float along and fit into that activation site, and the process happens again. Okay? So from here, once our enzyme has binded to our substrate, this actually gets broken down. So our lactose molecule gets broken down into our products, which is glucose and galactose. Okay? All right, so something else we have is induced fit theory. Okay, so with induced fit, I'm just going to kind of mention it just a little bit. What happens is if we have an enzyme that has kind of a funky little shape on it where our substrate doesn't fit, then this active site right here is going to change its shape so that our substrate can fit in perfectly like a lock and a key. Okay, key and a lock, sorry. Okay, so how would you know if we have an enzyme? Well, enzymes actually most of them end in ASE. Okay, so for example, like we talked about up here, we knew that this was our enzyme because it ended in ASE, lactose. Lactase. Another example would be amylase, like we talked about earlier, which you can find in your saliva. And amylase also ends in ASE, so that's how we know that that's an enzyme. Okay, so I want you to think about these, for example. If we need an enzyme that breaks down protein, Think about it. What do you think our enzyme would be for protein? It would be protease. Okay, if we need an enzyme that breaks down lipids, what do you think our enzyme would be? Lipase. Okay, most of the time this works. There are some enzymes that do not end in ASE, but for now, all you need to know is that most of the time that you see a word ending in ASE, it will be an enzyme. Okay. The last thing I want to touch on is things that impact enzymes or denature them. So when something is denatured, that means it no longer functions properly. Okay. So a few things that impact enzymes is the temperature level. So if it gets too hot or too cold, it could cause the enzyme to not work properly. Same with pH level. If it's too acidic or too basic, then it could impact how the enzyme functions. Also, the amount of substrate and enzyme that's available could also impact it. And lastly, activators and inhibitors. So activators are things that help the process continue, or inhibitors are things that prohibit the process from happening. Okay, so just a little rundown real quick. We know that with enzymes, we end in ASE, and they are proteins. We have a enzyme here, and our substrate that binds into that active site. Okay, we talked about induced fit and lock and key theory. So just to show you a few more examples, if we had this as our enzyme, we would need a substrate that fits directly inside of that active site. Okay, so if we look here, this would be our substrate that would fit into our active site. Okay, another example, if we had this as our enzyme, we need something that fits like a key in a lock. So this right here would be our substrate, which fits directly into our enzyme. Okay, hopefully this helps on enzymes. Hopefully it's a little bit of a review. Otherwise, I look forward to seeing you guys again tomorrow.